Okay, so let's take a look at the first part, okay, of your further Trigo. Okay, so this part is basically, okay, when we work with Trigo of your obtuse angle. Okay, essentially these are formulas that you all need to memorize. Okay, why we say obtuse is because when we work with all of these, okay, identities here, okay, we are assuming, okay, this is under the assumption that theta is acute. Meaning to say, theta is between 90 and 0. Okay. So with the concept, okay, essentially, okay, all you need to do is to memorize. It's very simple. Okay. So for sine theta, the other, okay, sine of the other obtuse angle itself is also the positive. Cosine and tangent, they are both negative. That's all. Okay, so memorize it as such. Okay, only sine, the other half of the counterpart is positive. Okay, for cosine and tangent, they are negative. Okay, so subsequently, when you all apply this into the back parts of this concept itself, the most important thing is whenever you all do sine inverse, okay, you all must take note that there will be two answers. Okay, example. Okay, let's say if I tell you, if I solve for theta, okay, and then I have sine inverse of maybe a value itself. Let's say I put 4/x7, for example. Okay, if you key this in a calculator, okay, you all will get 34.850. Okay, 5 first. But you must also consider theta could also be 180 minus this as well. Okay, so this is one key concept that you all need to take note of when you all do solving subsequently. Okay, whenever I do inverse of sine, there are two possible theta values. Okay, one is the acute value and the other one is the obtuse value. Yeah, okay. Okay, so with this in mind, okay, since sine is the only one with two possible answers, okay, for cosine and tangent, you do have to consider this other scenario. Okay, so let's see how you apply these identities in the question itself. Okay, so whenever the question asks you, okay, be it sine theta, cosine theta, or tangent theta, this I'm asking you for the Trigo function and the ratio itself. The answer should be a fraction. Okay, whenever I ask you for any of these three, okay, I'm not asking for theta value. Okay, so please don't go and do the inverse of sine, cosine, tangent. Okay, it's just a ratio itself. Okay, so for example, given this diagram itself, okay, you are asked to find sine of angle DBA. So DBA is this angle here. We know this is the obtuse, right? So we work with the right angle triangle first. So basically, angle sine DBA equals to sine of DBC here. Okay, which is opposite over hypotenuse. So whenever you have such questions, the first thing you all should do is, okay, use Pythagoras theorem first, okay, to find the unknown side. Okay, so DC by extension, okay, is basically square root of 41 square minus 40 square, right? And then you get the value of 9, which is what you have above. Okay, then I'll label 9 in diagram. So opposite over hypotenuse is just 9/41, and that is it. Okay, you don't have to sign inverse because I am not asking you for the angle value itself. Okay, next, cosine angle DBA. Same thing, cosine angle DBA is equals to negative cosine DBC. All right, so that's negative adjacent over hypo, which is 40/41. That's it. Okay, so all this you just need to memorize the identities. Okay, only sine counterpart is positive. For cosine tangent, it's negative. Okay, let's look at the next part. Okay, this example here. Okay, the most important concept I want you to highlight here, the concept of 90 minus theta. Okay, which I'll use the example to go through. So again, you are given a diagram, okay, with a right angle triangle, okay, label with a theta, and then you sine theta equals to 8/17. Okay, so sine is opposite over hypotenuse. So label the triangle first. With reference to this angle, your opposite is BC, your hypotenuse is AC. All right, so to find AB first, okay, use Pythagoras theorem again, which is what you have over here. Okay, you get 15. So immediately just label in your diagram here as 15 first. Okay, so if I ask to find cosine theta adjacent over hypo 15/17, that's it. Okay, simple as that. Okay, the key concept that I want you to take note in this example here, okay, which is new, is this 90 minus theta. What is 90 minus theta? Okay, 90 minus theta is always the remaining angle that you have here, because essentially if I ask you to find this triangle, the angle here, it will be 180 minus 90 minus theta, and you simplify, you get 90 minus theta. Okay, so this angle here is a 90 minus theta. So tangent of 90 minus theta. So with reference to this angle here, my opposite is 15, my adjacent is 8. So tangent is opposite over adjacent, right? So 15 over 8, that's it. Okay, then just further simplify it because this is an improper fraction. This is 1/7 over 8. Okay, then for part C and part D, okay, standard stuff. Cosine 100 equals to cosine theta, right? With a negative because the cosine counterpart is negative. So over here, cosine 180 minus theta is negative cosine theta equals to negative adjacent over hypo. That's it. Okay, or you can just answer from part A because part A is cosine theta. Yeah. Okay. Then sine angle ACD, which is this angle here. Okay. So first things first. Okay. Essentially, I know. Okay. Sine of angle ACD. Okay. Again. Okay. This is the obtuse, right? So it is equals to the acute as well of sine ACB. So same thing. AC and sine angle ACD equals to sine ACB. Okay, then just say 15 or 17. That's it. Yeah. Okay. This next example of 6.1c, this one is the concept. When I ask you for possible values, okay, this one is where I mentioned earlier. When I have inverse sine, okay, I have two values. Okay, the acute possibility and the obtuse. Okay, possibility. So for example, if sine theta equals half, okay, if I inverse sine half, I get 30. But okay, using the same concept, sine 180 minus theta also equals to half. Okay, so theta can also be 150. Yeah, okay, so the way to do this as well is, okay, first you work off with this version first. So from this, I work out theta as 30. Or theta is also equals to 180 minus 30, which is 50, that's it. Okay, so you all can skip this chunk here essentially. Can? Okay, so this is the main concept that I highlighted earlier with the two possible angle values for inverse sine. So with that, okay, that is your triple identities, okay, and how you apply them, okay, for your 180 minus theta for sine, cosine, and tangent. Okay, the next part that I'm gonna do with you is now when you learn a new formula for area of triangle, sine rule and cosine rule. Okay, so let's look at area of triangle first. So first things first, these subsequent formulas that I teach you all, okay, it is only for non-right angle triangles. Okay, all these are for non-right angle triangles. If I have a right angle, right, the terms A, B, and C, you all must know how I look or how I determine, okay, which I'm using. So first things first, whenever I draw a triangle, let's take reference to this triangle itself. Okay, if I label this triangle ABC, okay, why I label this side small a is because the angle A here will correspond to the side here. It is always the direct opposites. The angle B here will correspond to the side B here. Same thing, my angle C here will correspond to my side of C here. Okay, so this concepts of you all must know which angle corresponds to which side. Okay, and very simple. How to determine? Okay, it is always the direct opposite. Okay, half AB sine C. Okay, the key concept is the angle must be in between the two sides. So if you take a look at the angle C here that I'm looking at, okay, it is formed between the two sides of A and B. Okay, so this is the key thing you must take note when you apply half AB sine C. How we further apply this formula into a question itself is, okay, look at this example here. Immediately, I want you to be able to form the link. When I talk about shortest distance, okay, shortest distance is equivalent to perpendicular distance. Okay, this link be in your head. Immediately when I ask you shortest distance, you must tell me is perpendicular distance. Okay? So how do I do such a question like that? Okay, look at an example here. So for example, if I got a diagram, okay, with the values, okay, the diagram here given to you. Okay, part A, nothing new. Okay, it's just application of formula. Area of triangle BCD. Okay, so BCD is the smaller triangle here. I have the two corresponding sides and the angle that is formed between the two sides. So just take area of a triangle BCD, half times 3.8 times 5 times sine 180 degrees. Okay, put to 5SF first because this is a part A. Okay, then subsequently you put as 3SF. Okay, part B is the one that we apply the shortest distance concept. So again, immediately when you all do question, shortest distance, underline put perpendicular distance. Okay, so what you are doing here, okay, is basically, okay, equating the two formulas of area of triangle. Okay, so of course, what is done in for you in the notes is, okay, because in part A I already found it. Okay, so I will use it directly. What do I mean by this? Okay, so okay, when I say shortest distance from D to BC, essentially I'm asking you to find this perpendicular distance here, where it's 90 degrees. All right. So start off by introducing the unknown first, because there's no way for me to annotate this length here. So we say let the distance be D first. Okay, small d. Okay, if you find it confusing because it's capital D here, you can use X as well. Doesn't matter. It's the same concept. Okay, so half times the base of BC times height, okay, of this shortest distance or perpendicular distance, it will equals to the area, right? So essentially, that's why they equate it to the 9.035, which is the value you found earlier. Okay, and then just bring over the half, bring over the value of BC. Okay, can? So this is under the assumption that we are given BC. Okay, so just label in your notes first. Okay, put 7.15 here first. Okay, this is one way of doing it. Another way, okay, where I mentioned this part here, I asked you all to equate the formula. Okay, so assuming that in the question, in part A, I haven't asked you to solve for area of triangle BCD first. I directly asked you to find the shortest distance. Okay, when I say equate, so this is what you all will do. Half times BC, okay, times D will equals to half times 3.8. All right, basically what the formula that you apply times 5 times sine 108. Okay, so if you realize on both sides the half can cancel out. So D will basically be 3.8 times 5. Okay, just key in the calculator. Okay, you get 19 sine 108 divided by the value of BC, which is 7.15. Okay, then you'll get the same answer. Okay, this is another way of looking at it. Okay, in the notes, the example given to you is because I've already found the area previously. That's why I use it directly. Okay, but of course, I have asked you to find. Okay, start off by this first. Okay, equate the two ways of finding area of triangle. Okay, this one is using half times base times height. This is half A B sine C. Okay, and the very last part, okay, is when you all learn, okay, your sine rule and cosine rule. So this is only applied for non-right angle triangles. Okay, if I have right angle, please don't use sine rule, cosine rule. Okay, it is not time efficient. If it's right angle, you either use Pythagoras theorem or your Torcaso. Okay, please take note of this. Okay, so sine rule and cosine rule. Okay, let's look at the rules individually. Okay, for sine rule, okay, where the A, B, C come from? Same thing, you take reference to a triangle. If I label this triangle ABC, okay, this angle B, right, which means correspond to this is B. This angle C correspond to this side is C. This angle A correspond to this side is small a. Okay, so it's okay, it's either to find an angle or to find a side. So this is when I want to find an angle, which is why I place the angles as the numerator. Okay, or sine of the angles as the numerator. If I want to find length, then I put the length as a numerator. So to find angle, when I apply sine rule, I need two sides and one angle. Okay, if I'm finding length, I need similarly, okay, instead of two sides, one angle, it is flipped. I need two angles and one side. Okay, can later on when I go through an example, it will be clearer. But basically, these are the scenarios that I need to fulfill to determine whether I can use sine rule or not. Huh? Cosine rule. Okay, there are two forms. The first form is this. This is if I want to find length. Okay, so to find length, okay, for this scenario, I need two sides and the included angle. What do I mean by the included angle here? Meaning to say, okay, if I am solving for A, okay, again, I label the triangle ABC here. Okay, this will be B, this will be A, this will be C. Okay, assuming I want to find your side of A. Okay, the small a here, which is the BC. Okay, I need two sides. Okay, your AB and your AC, which is B and C, as well as this included angle here. So included angle just means the angle must be in between the two sides. That's it. Okay, the angle must be in between the two sides. Okay, and the side that I want to find obviously is the one that is directly opposite the angle itself. Okay, this is to find length. Okay, this form here for cosine rule. If I'm trying to find angle, then this is the form that I use. Okay, this form is to find angle. Okay, to find angle, I need. Okay, earlier was two sides in the included angle, right? This scenario, I need all three sides. Okay, can. So basically from here, okay, if you look at this form here, it is just manipulated from the first form that you have, okay? Where the first thing that you do first is a b squared c squared over first, and then divide negative throughout. Then you just divide the 2bc over. Okay, so do this, okay? Can? So let's take a look at how you apply these formulas into the question itself, okay? So examples of use of sine rule. The first one here, okay? I'm finding a side, right? I have two angles and one side. So over here, I have 2a, 1s, right? I can use sine rule to find the other side. So I'm finding x, which is why I place it as the numerator. So x will correspond to the 40 degrees. That's why it is x over sine 40. This 12 will correspond to the 105. Okay? So to find x, you just multiply over the sine 40. That's it. Okay, again, leave it as 5SF first, then 3SF. Okay, just make it ahead. Okay, the second example, okay, I want to find theta, which is the angle value itself. So this one, I have two sides and one angle. Okay, this angle corresponds to this side. Okay, but you realize, okay, now you have an issue. This 8 actually corresponds to this. Okay, it doesn't correspond to the theta that I want to find. But if I can find this angle here, I can take 180 minus 80 minus this angle, and then I can find theta using angle sum of triangle. Okay, can? So which is why in the notes you say, use sine rule first to find angle ACB. Okay, then use sum of angle and triangle. Okay, so again, just apply the sine rule itself. Okay, multiply the 8 over, do the inverse of sine. So work this step by step, please. Okay, don't key everything in the calculator. So that's why I see in the notes. I work out what is sine 80 over 12 times 8 first. Okay, put it as a 5SF form, then you inverse sine this. Okay, and then I get 41 degrees. So I know that's not I mentioned for inverse sine, I got two possible values. But clearly, if I work with this angle here, it has to be the acute version. So don't even need to consider the obtuse possibility. Okay, and then just take 180 minus 80 minus the 41 that you found here. Okay, then over here, put angle sum of triangle. Okay, the next example is how you apply cosine rule. So again, if you take a look here, this one is where I have two sides and only one angle. Okay, so I apply a cosine rule. Okay, so immediately just put, okay, x squared will equals to 8 squared plus 5 squared. Okay, there's a typo here. It should be plus. Okay, then change it to minus. Okay, minus 2 times 8 times 5 cosine 48. Okay, and then after you just square root the value itself. Okay, can. And then same thing, 5SF, then 3SF. Okay, standard stuff. The other application is if I am given 3 sides. Okay, I find the unknown angle itself. Okay, so the one that should be on the left-hand side should be the side that corresponds to the 5. Because 5 is the side that corresponds to this theta value itself. Okay, so okay, write this out. Okay, simplify and do the manipulation. Okay, then after that, divide the 192 over. Okay, which is what you have here, and then do the inverse cosine. Okay, and then it's 17.6. Okay, angles always to 1 dt. Okay, which is what your final answer is to 1. Okay, same thing over here, 1 dt. Okay, can. This is for your cosine. So the last part, okay, is an overall example at how you determine what to use and what to solve. Okay, so take a look at this. Okay, I have a part PQRS. Okay, where you have certain values given to you and it's all labeled in the triangle itself. Okay, they ask you to find the length of QS. So QS falls in 2 triangles. Either I use PQS or QSR. Look at the triangles that you have and see which one you have information to use. So if I look at QRS, for example, if I want to find QS, I only have one angle, one side. Right? There's no rules that only require one angle on one side. I need more information. So I look at the other triangle, PQS. PQS, I have 2 angles and one side. Can I find another corresponding side? I can. Right? Okay. So one thing I want you to take note first is 55 corresponds to QS. Yes, I can use that directly. But this 38 corresponds to PQ, which I don't have the length for. What I have the length for is for PS. So can I find out what is this angle here first, so that I can use it with the corresponding 460? Yes, right. Because I have 2 angles. So use angle sum of triangle first. Okay, which is the first part here, where I find PQS. Okay, write the reasoning here. Angle sum of triangle. Okay, then you're going to do the application of sine rule itself, find the value of QS as such. Okay, simple as that. Okay, so again, take note, because there are multiple parts, write the 5SF value first, then you write the 3SF value. Okay, because subsequently, when you do the later parts, okay, where you have to use QS, if you don't use the 5SF value, your accuracy will be off, your answers will be wrong. Okay, for part 2, okay, now that we have worked out QS, okay, have the habit, go and write down the value in your working itself or in your diagram itself. So this is 337.32. I'll label it here first so that I know that I have it. Okay, now I want to find RS. Obviously, RS, I'm using the smaller triangle, right? I have 2 sides and 1 angle. Okay, so to find RS, I should be applying. Okay, just go through in your head. Do I use sine rule or cosine rule? If I want to use sine rule, I need another angle, right? Which I don't have enough information to find. But what I can use is cosine rule. Okay, so part 2 is actually using cosine rule. That's it. Okay. Part 3. Okay, what is the shortest distance? So shortest distance again linked to perpendicular distance. Okay, so between Q and PS, which means when I draw a vertical line down. Okay, when I draw a vertical line down. So, okay, there are 2 ways to do this. Okay, I'm going to go through the first way first, which is the standard way that we always do it. Okay, so shortest distance is basically when I say equate your 2 ways of finding area of triangle, right? So for this one, to find area of triangle, the half AB sine C will be half times QS times 460 times sine 38. Okay, which is what you have here. Okay, then of course the other way is to use the perpendicular height here times the base of PS. Okay, so if you realize actually from here, okay, before you even do any multiplication, okay, I know this part looks a bit complicated. So, okay, I want you all to don't look at this first. Focus on what I have here first. Essentially, you realize half and half can cancel out. PS and PS can cancel out. Right, so essentially, D is basically QS times sine 38. All right, and then QS earlier you worked out already, which is this value here. Okay, they just key in the calculator, equals to 377.33 meters times, sorry, 1100 meters times sine 38. Okay, and then key in the calculator, that's it. Okay, this is the standard method. Another method you all can use is, okay, so this other method is good to know. Okay, so you know this is a perpendicular line, right? So can you all see actually you all have a right angle triangle here? My Dwaka, so because why? I have the value here of QS, which is 337.33. So with reference to this angle, I got one side, I can find the height here as well. Hypotenuse opposite. I can use sine 38 equals to my perpendicular distance D over 337.33. You will realize you also get D equals to 337.33 times sine 38, which is exactly what I have previously. Okay, so there are two ways of looking at it. Okay, why did I not introduce you to this method at the start? Is because this doesn't apply for all questions. Not all the time I have a side that I can use. Okay, but using the equating of both formulas is something that I can directly use. Okay, so in your notes itself, okay, please take note of this and write down this other method. Similarly, for this form, the method one, so this method one, okay, where you equate formula of area of triangle. Okay, method number two is applying Wakaso. Okay, but for the first method, take note, I don't want you all to just make it so it's too complicated in this form. Okay, immediately, if I have something common, go and do the cancelling like the half and the PS. Okay, then I can simplify. D will equals to QS times sine 38, which is what I wrote for you all here. Okay, so please make this edit in the notes for yourself. Okay, and lastly, find the area occupied by the part. Okay, it is just the two triangles that you have here. Okay, so just add up the two areas of the triangles here using half AB sine C, half AB sine C. Okay, that's it. Okay, so with that, essentially, that's all the concepts that you all need to know for further Trigo. Okay,